Good afternoon, everybody. I hope you're well, and if you're listening, watching this from anywhere in the UK, it's nice and hot and sunny for you. Before we get started, I'm just going to wait a few seconds, maybe a minute, for a few more people to join. So just bear with me for sort of 30 seconds or so, so we get everybody on board. Right, well, I think we'll make a start. My name's Jonathan Lowy, I'm from VMZINC, and we're gonna go on a little bit of a trip around the world, not quite following Phileas Fogg in Jules Verne's Around the World in 80 Days, but something a little bit similar. You'll see lots of projects, obviously lots of zinc, but other materials, different types of buildings, so hopefully it'll be of interest. If you do have any questions, please write them down, put them in the question box, and we'll have a question and answer session at the end. So the presentation should probably last about 40 minutes, and then we'll have a good 10 or 15 minutes for questions and answers. So I'm going to get rid of the webcam so you see my screen, and off we go. So, around the world in 80 zinc projects. That was what Phileas Fogg did. We're going to do something similar, but not quite the same. So, not really a project, but just to give you a little bit of history, Jean-Jacques Dony was an abbot come amateur chemist, and he was one of the first people to extract zinc in its pure form at the turn of the 19th century, about 1800. One of the few things he found to do with it was to make what you see on the bottom left, Napoleon's bathtub. And that apparently was carried all the way to Moscow, top left, and back again. About the same time, actually slightly earlier than 1812, in 1809, the first zinc roof was installed in what's now Belgium, Liège, the St. Bartholomew's church, and the church still exists, and it still has a zinc roof. It has been replaced since then, but it's fundamentally the same building. Moving on just a couple of decades to 1830, sort of about the time of Les Miserables, the first imperial roofs were being installed in Paris, and these type of roofs are still seen today. On the right, you can see a drawing with people making ornaments and batten cap roofs, and on the left, that's actually a photo from the Rue de Rivoli in central Paris. But the guy who really got things going as far as zinc was going and as far as the development of Paris was Baron Haussmann, who was basically Napoleon III's town planner. And he had the mission of taking central Paris out of the medieval ages and into the modern 19th century. And the grand boulevards were built as you see them today. And one of the requirements was to have a low slope roof, often combined with slate. Obviously, the grand boulevards, one of the ideas behind it was that a small group of soldiers could fire cannonballs down, stopping demonstrators. Not too long after that, in the UK, zinc was being used. Zinc isn't new to the UK. In fact, it's been used all over the world. But in the UK, Liverpool Central Library was built in 1879, and about 130 years later, Austin Smith Lord did an extensive renovation, including of the Picton reading room. And this was be replaced with zinc, and hopefully it will last another 100 years or more. But that's enough from Europe. We're going to get on a boat from Liverpool across to New York, more precisely Brooklyn. This is a project by Shop Architects, which is part of the Domino sugar site, which is a very large development, and this is a mixed-use building, and it fits in between the high rise of Manhattan on the other side of the river and the low rise of Brooklyn. And the system that's being used is natural zinc with perforations, giving this very interesting, elegant texture. Now, still in New York, but this time actually in Manhattan, we're going to talk about or look at something that's not zinc. This is obviously copper. The Hadrian building was built in 1903. And back then they had a cornice which was actually made out of galvanized steel and then painted to look like copper. This, by about 10 years ago, this had really all completely fallen apart. And the new owners wanted to give this old building a new life. And part of it was to build these cornices. Now, we don't refine zinc, but we don't refine copper, but we do manufacture copper products. Copper and zinc are quite similar in their properties. Copper's obviously red, but it can be stamped, soldered, spun, embossed in a similar way to zinc. So this could have been in zinc, but it's in copper. All these stamped products, and you can see some of the soldering. This cornice should really probably last a lot longer than the original one, which was in galvanized steel. Now we're going to go a long way south and sort of stick in the Jules Verne theme. This is the lighthouse at the end of the world. And Jules Verne actually got this idea from a lighthouse that did exist in the bottom of South America, Tierra del Fuego. On the bottom right, you can see a sketch of the lighthouse, and a French sort of explorer, I suppose, had the idea of rebuilding this lighthouse, which had really become a ruin. A guy called André Bronner got a group of companies, including VMZINC, together, and we all contributed basically. And on the top right, you can see the lighthouse with the zinc roof. This was done about 20 years ago. Now, it's obviously not very easy to get to, very exposed by the sea, windy, a long, long way away. But André Bronner did build a similar one in the Bay of La Rochelle. So once we get through the current crisis, if any of you in Western France near La Rochelle, you can go and visit that, and you can see how well zinc actually works in a marine environment. This is actually in the sea. Just moving up through South America, here we've got on the top right, sorry, is a villa in Argentina. Now, Buenos Aires is sometimes known as the Paris of South America, and zinc has been used as a traditional material for quite a long time, but obviously not to the same extent as in Paris or other European cities. But in the middle and on the bottom right, there's a hotel in Sao Paulo, and on the left, a rain screen roof in quartz zinc, again in Brazil. Now, moving up through into North America, New Orleans. I don't know whether any of you remember the disaster of Katrina that happened 15 years ago now, which really was about over 2,500 people died in the floods, but there were severe winds of up to about 135, 140 miles an hour. These two buildings are actually, one on the left is a primary school designed by Wagner and Ball in New Orleans using a zinc rain screen in quartz zinc, and on the right, a church just outside New Orleans on the south side of the river by Escu Dumes Ripple. The before and after photos from a zinc perspective are very similar. The zincs performed very well as a real hurricane test. On the church, windows got blown out and the flat roof actually peeled off, but the zinc remained completely intact. Just moving a little bit to the west into Phoenix in Arizona, Gabor Laurent Architects built this police station, silver LEED accredited building. With the idea is to have this zinc screen to give the building a bit of lightness. You can see the variation of the perforations. Obviously, perforating zinc is not a problem because you're just perforating a solid material, not exposing any other material. It's not like perforating steel where you're going to be exposing bare steel. So that's not a problem and works very well. Now this is an interesting project in Chattanooga by Randall Stout, who passed away a few years ago. It's a museum, and you can see on the left the building sits on a rocky limestone outcrop above the river. The original idea was actually to use limestone as the cladding material. That would have created an awful lot of cost because of the weight of the cladding would have increased the structure and therefore the cost. So a solution was to use pre-weathered quartz zinc, but then to further weather it. And this was done with a company called Zana. And you can see it's a fairly uneven finish, but it almost has a stone-like feel to it. And then a little bit further up towards the Canadian border in New Hampshire, this is a project which is an observatory. And again, with the stone, this is actually granite, and there's a connection between the materiality of the quartz zinc and the granite around there. The inside of the building is much softer with timber, but the architects have taken the quartz zinc flat lock panels from the outside to the inside of the building in quite an effective way. Now going across the border into Canada and Le Mont-Royal, or better known as Montreal, on the left there's kiosks, wind-blown kiosks. I think you can see why they're called wind-blown kiosks. They've got a slight slant to them. And then further down the hill, which Montreal is sort of formed around, is a part of McGill University. And this is the arts building that was designed by Soucy & Perrot. And you can see that there's almost an idea of musical notes on the right, mixing glazing with quartz zinc and anthrazinc. And further west towards Calgary, or in Calgary, I should say, this is a university building, and one of the many retrofit renovations. This building's been completely regenerated and then reclad using anthrazinc flat block shingles in a very effective way. And then right over to the west coast, Newport. This is a Boland Sawinski Jackson project, where again there's a mixture of materials that are used. There's a lot of stone and timber, and obviously you can see in this photo the zinc flat lock panels. We quite often get asked about, well, where do you use zinc? You've seen there's been a wide range of buildings from new to retrofit, but we also get involved in a lot of residential projects. The left is a building in Toronto, and bottom middle is also Toronto, a very different scale. Top middle, it's sort of difficult to see where that could be. It's actually in New Orleans again, and then on the right in the desert of Arizona. So a wide range of private houses, but all using zinc in slightly different ways. Now we're going to jump on a plane, or maybe a boat if it was Phileas Fogg, and go across the Pacific to New Zealand. And here it's a sports centre where flat lock panels have been used again to give the facade texture, but the actual substrate is obviously got a 3D effect to it, giving a very original facade to this building. I don't know whether any of you have been watching the luminaries, gold rush in the South Island of New Zealand in the 1860s. Well, this is probably set, this building's quite close to where that was set. It's by Coyer Architects, again a combination of zinc and wood, extensive glazing, obviously taking in the quite incredible views of such a remote location. Then here there's some zinc used on the facade, but the main use is on the standing seam roof of the private house. Just going a bit further west into Australia, the project on the left is called the Glass House by Croxon Ramsey Architects, and they've used anthrazinc on this sports centre for the Collingwood Football Club, whose colours are actually black and white. Not Newcastle, but Collingwood, black and white. And obviously you can see they've used the anthra as the black, and then there's quite a lot of render, which is the white. On the right, Bondi Beach. Zincs, as I said earlier, a very good in a marine environment. It performs very well, very low corrosion rates. You have to be a little bit wary of non-rinse surfaces, soffits that close to the sea. There could be staining, not significant corrosion, but just staining. Now again, little trip around Australia, private houses using different techniques, standing seam, interlocking panels, pigmento zinc, which is zinc with a slight pigment to it. And on the bottom right, you can even see a zinc clad aquarium, which is something that's a little bit original. Zinc going from the outside to the inside, which is I wouldn't say common, but it's done more and more, giving a sort of a common material running inside to outside. And then across to the west coast of Australia, in Perth, there's a stadium, the Opto Stadium, which is by HKS, Cox Architecture and Hassel Studio. Lots of materials used on this, but the front entrance sort of area is again a flat lock clad building, giving this curved shape. Staying in the idea of curve forms, but moving further north to Japan, Nikken Sekkei have done this office building using engraved Azingar, which is zinc that has a slight texture to it. Pre-weathered zinc has a texture, but it's really only visual. Azingar actually has a physical texture. You run your hands across it, and you can actually feel the texture of the zinc. And to South Korea, a dinosaur site or a dinosaur museum. You can see where the dinosaurs have been running around millions and millions of years ago, and there's an interesting structure which has then been clad in quartz zinc. Moving down to Taiwan, here we've got very different type of architecture, very different type of use. The Towers One Park, which are two 35-story buildings in Taiwan designed by Roger Sturck Harbour. Zinc's been used, it's a honeycomb panel, honeycomb backing, giving stiffness to the zinc, but it's used here as a rain screen. So there's the column covers and the detailing around all the windows all the way up to the top of the buildings are in the quartz zinc. This is an interesting building, not too far away in Hong Kong, the Kennedy Pool by Terry Farrell. The interesting part of this, I mean, there's quite a few interesting things, the design, the forms, but if you look on the left, the right part of the building was built in 2011, and the left part of the building was built in 2018. And one of the reasons for using quartz zinc was to use a material that really wouldn't change. So it was always going to be built in two phases with a number of years between, in this case 7. And now when you look at the facades, you wouldn't really know that they were built at 7 years interval. Staying in Hong Kong, well, on the left it is, on the right it isn't. On the right, you saw on the previous photo ornaments. Now here are ornaments in zinc, natural zinc, which have been stamped, soldered, in some cases spun. This is actually an example of a roof in Switzerland. But on the left, you've got an ornament facade, you could describe it as. So you've got a little bit more than just straightforward panels. There's some quite complex ornamental facades, let's say. And this is something we use old techniques to create new design. So you can take some of the old techniques used in the production of traditional ornaments and apply it to modern designs. And on the left, that is a facade of a building in Hong Kong. Moving mainland China, Datong, this is a large stadium designed by Populous, who have used pigmento blue panels on this very curved bulbous form. And this still in China, but quite different. Shanghai Douche Architectural Design have built this building in a very traditional part of Suzhou, and there was a requirement to make sure that it looked like it was fitting in with the local architecture. And I think there's no doubt, looking at those images, you would know exactly where that is in the world. Whereas the next photo is clearly not something that it could be anywhere, and you might see it's in China, but that type of design really could be anywhere. It's something which is using standing seam in quartz by a riverside, very dramatic forms. Sort of staying somewhat in the dramatic, but down in Singapore, on the left, there's Fullerton Square, which uses a number of quite complex geometries. And on the right, there's the theatres on the bay. If you're careful when the Singapore Grand Prix is on, I know it's at night, but the cars fly past quite closely to both those buildings. Something that's important to point out here is that the minimum slope for a zinc roof is 3 degrees. It's not a flat roof material. It does need to shed water. And whether that be in Singapore or in London, it's the same rules. The water needs to shed, needs to be at least 3 degrees as built. Now, I don't know about you, but I sort of always get a feel that I'm looking at a Frank Lloyd Wright type building here. No water, but the overhangs, the cantilevers sort of give that sort of feel on a hillside. But this hillside is in India, so maybe not where you'd think it might be. Again, using quartz zinc on covering these nice cantilevered balconies. Staying in India, this is a shopping centre which has been using a very complicated geometry. Again, zinc being so malleable and flexible can deal with these sort of details, and Practice Design, who have designed the shopping centre, wanted to really create a strong feature at the entrance point, which I think they have achieved. And moving a little bit further, or quite a lot further west into Turkey. Here we've got a museum, the Bursa Panoramic Museum, a sphere. You can see on the majority of the sphere, there's again quartz zinc panels, but with variations on sizes of the panels, giving us sort of a texture. And at the very top, there's the standing seam part, which will mean that the building is going to be kept weather tight. If you use a flat lock panel on a very low slope, the water's going to get inside. So the top of the dome or the sphere has been covered with a standing seam panel. And just moving into the Mediterranean, this is in Limassol in Cyprus. This is a port building, which actually won the 2017 Mies van der Rohe Prize, Erwin Kriatotti Architects, for this. I think so. It's a pretty attractive building. Some of the forms really work well in this port environment. Very different. Move to Italy now. Zinc sometimes is considered as something that's a bit soft and rounded, and we've seen it very much can be. But here, pigmento blue panels, which have this slight pigment to them, are used with interlocking panels, giving pretty sharp angles. It's a private house in Italy, which can deal with this angular type of design. You do need to use the right panel, but zinc can do that. But back to the round and the curvy. This is a project which a theatre complex, 2 theatres within this building, and you can see some of the openings for ventilation have used expanded zinc, which you can see on the right, which works very effectively. Now further north into Switzerland, and apologies for the stereotypes, but there's a cable car station in pigmento green zinc in a rain screen panel, and then a railway station in pigmento red using a more traditional standing seam panel. And sort of almost staying in the Swiss stereotype, railways. This is quite an old project now, going back to the late 90s. Herzog and de Meuron, who created this engine shed basically near Bâle, auf dem Wolf. Into Austria. This project is the Krems Art Gallery, which uses Azingar, so it's the textured zinc, to create these quite dramatic forms on the edge of the Danube. You can see the Danube in front of you. There was really a statement by the locality to produce an outstanding art gallery, and it's pretty spectacular. Into Switzerland now, and three quite different buildings. Bottom left, fairly classic for zinc. Wroclaw railway station. Railway stations often have zinc roofs. Zinc lasts a long time, low maintenance, and therefore fits in quite well with railways. Top left is a residential project, and on the right, zinc tile, something called Adica, on a church. Now moving into Germany, this is Wismar, which is now it's a UNESCO heritage site, and Star and Partners took a very old derelict site and connected two parts of the town to create this sort of vibrant environment. And I think what's really great about this is the way that the zinc and the brick really work beautifully together. Very traditional, standard standing seam, but simple and effective. And on this slide, you can really see how harmonious the zinc and the brick is. It looks like it was actually completely designed to go together. Still in Germany, in Hamm, we've seen projects like this, residential projects, fairly angular, this in an anthrazinc interlocking panel. The oddity here is it's on the top of an old air raid shelter, which is a little bit original. And some of that air raid shelter is used for the building, for access, obviously, stairways and so on. Now into Denmark, Odense or near Odense, Cornelius and Vogler architects designed this cultural centre, which is orientated around Greenland, Iceland, and the Faroe Islands. The idea behind the corrugated anthrazinc was one of the blackened wood that's often used in those countries, and also the geology, and the dark angular zinc fits in with both those. So there's a language across this building. And into Sweden, here there's on the left and then in the middle, top and bottom, it's a residential project in Stockholm using anthrazinc, pigmento zinc, quartz zinc, standing seam on the roof, and a sine wave on the walls. On the left, it gives me a feeling of Bauhaus balconies. And on the right, something completely different. It's a little private house in Sweden with natural zinc. And this is, again, a very interesting renovation or extension project where Studio Mark have connected old and new with a lovely glazing connection piece where you've got the old with the thatched roof going into the new with the zinc standing seam roofing and cladding. Still in Holland, and still an extension. It's fairly common that zinc is used on extensions, renovations, retrofits. Here we've got an 1895 hospital where IAA architects used a modified batten cap wall cladding system to extend to the old hospital. And again, you can see on the photo on the right behind the geraniums, the brick blend or fitting in, or the zinc, I should say, fitting in well with the brick. There's pigmento brown zinc and that sort of reddish browny brick, which work really nicely together. And then now into Belgium, old and new. The left is, I have to be honest, I haven't seen too many petrol stations like that. It's quite a spectacular one, completely clad in zinc standing seam, wrapping round and over, continuous roofs to walls. And on the right, you've got the Antwerp Opera House with zinc and a very traditional zinc ornament. And staying in Belgium, this is a mixed-use building, which is sort of on the edge of a town, going into the countryside by a motorway. So there's lots of stuff happening here. And the architects wanted to have a facade which wasn't completely opaque. They wanted to give it, they wanted to perforate it, and on the inside, you get the feeling that you can actually, that you can look straight out and you can see the outside. There's a sun shading effect from the looking towards the building from the outside. It doesn't look completely solid, but it's obviously you've got a slightly transparent feel to it. Now, this is a building again in Belgium. This is the VMZINC, which VM stands for VMZINC, which is Old Mountain in French. And this is very close to where the original mine was. It was the Old Mountain mine. That mine has long been emptied of zinc, going back to the 19th century, but zinc continued to be produced in that part of Belgium into the 19th century, into the 20th century, sorry. And this is the old administrative building, which has been turned into a museum with an Azingar batten cap roof. And on the bottom right is part of the exhibit, and you can see some of the bits and bobs, tools and so on that were made from zinc. In the 19th century and certainly into the 20th century, zinc was a little bit the plastic of its day. You could make lots of things out of zinc, lots of tools, and obviously very, very easy to recycle. Moving into France, this is in the north of France, the north of Paris, where there's some social housing block that was built. It's in an area there was some small engineering, some sort of craft businesses, hence the name Craftsmanship Hub. And it fits in between buildings along quite a large road with different types of materials. So you've got some black brick, you've got some more classical limestone of Paris, you've got some render, and here you've got the Azingar, and you can see the Azingar it's matte, but it's also quite bright, which is an interesting combination. And on the bottom right in the distance, you can see some traditional dormer windows with zinc roofs to them with the clay tile roofs. That was designed by Bardier and Berger architects. And this is a medical center in southern France, where there was a desire to have somewhat of an abstract feel to the outside. And again, Azingar has been used, but perforated to create this pattern. So very simple, actually. Perforated sheets that have been fixed to an aluminium rail to create a rain screen. And just showing that zinc can be used in pretty much all climates. This is above Chamonix in the French Alps. You can see this is natural zinc on the right. It's quite shiny. The mountain climates are quite dry, so zinc needs two things for natural patina to form when you use natural zinc: water and CO2. If there's less water or there's no water, the patina doesn't form, or it takes much more time. This is a project in Bordeaux, southwest of France. One of the traditions of Bordeaux, actually not dissimilar to the UK, is terraced houses with no front gardens. So you basically open your front door and you're straight on the pavement. Now, this is a house you'll see in a minute on the next slide, where you see the original house, and the back of the house has been given a typical sort of Bordeaux design straight onto the pavement. There's you can see the block on the top left, which then you can see on the right, which opens into a courtyard using anthracite and quartz zinc. And then towards the back on the right, you can see, looking back to the original house, there's the courtyard with the original house in the background, which has been renovated and clad in part using quartz zinc interlocking panels. Down to Spain, there's flat lock panels on the right in quite an interesting sort of cubic form with pigmento green, and on the left in Reynosa, it was an old, fairly traditional Spanish market, which unfortunately burnt down, and Rohr de Abajo Garcia architects built this community centre. You see combining timber and zinc again in sort of a slightly modernized, but still reflecting some of the traditions of a central market that you'd find in Spain. And into Portugal. Here we've got a in the Douro Valley, which is the valley where all the grapes are grown to make port, which is east of Porto. This is an old railway station which has been turned into a cultural centre, a museum. And here's two quite different projects, both in Portugal. The top is an outdoor chapel, Zinc standing seam, clad a very, very simple timber structure, but really, really effective. And on the bottom is part of the Expo 98, which happened in Lisbon. And SOM architects have clad this large arena in quartz zinc, using some quite complex geometry and layouts. And we couldn't leave Portugal without having a little drink of port. And this is, I think, really quite clever, where the pigmento red, obviously reflecting the color of port, has been combined with cork, which is obviously what you need to keep the port in the bottle. So a nice sort of idea. And up into the North Atlantic, into Ireland, the west coast of Ireland to be precise. This is by Simon J. Kelly Architects. It's Patrick Pearce lived in the cottage at the beginning of the 20th century, and he was involved in a lot of traditions and culture. And this is basically a cultural centre, museum in the Connemara, which is a sort of a tribute to his work, clad again in pigmento red standing seam. And over into Scotland, Stirling to be precise, this is you can see an engine shed. It's still sometimes referred to as the engine shed, which had been derelict for a number of years. Two geometrically similar forms were added each side, clad in the zinc. And this is a cultural, again, a community cultural centre, a crafts centre where traditional crafts can be seen and learnt. And down into the north of England, again, a building very much connected to its environment. This is by Simpson Hoff Architects in North Shields, residential block. And on the right-hand photo, you can see an old warehouse in brick, which is obviously some of the inspiration for the buildings. So not only the color, the pigmento red, but the forms. And into London, Combe Peters and Fox Architects have taken a Georgian terrace, which had a concrete frame added to the top of it, and then the zinc in quite a complicated form, sort of has some sort of spacecraft feel to it to create a more office space, but it all blends really, really nicely. This is right next to, on the Marylebone Road, right next to Regent's Park. And staying in London, Scott Brownrigg Architects have designed this residential block which spans between Battersea Park on one side and Battersea Power Station on the other. And on the top middle photo, you can see how the height of the building drops down towards the park side, builds up towards the power station side. And on the power station side, there's a lot of pigmento red rain screen panels that have been used to clad the building. Staying in London, PLP have designed this office block in Mayfair with a pigmento blue shingle roof. Now, shingles, flat lock panels are normally only used on walls, but you can, as long as it's at least 30 degrees, they can be used on roofs as well. And this is, again, a retrofit, with an upward extension. You can see the old 1920s brick building, which still has, I think, a doctor's surgery and some shops in it. Above that, there's housing, which has been built and then clad in anthrazinc, corrugated zinc, perforated and curved. On the right, you can see the perforated panels, which are really quite transparent. Again, we've seen across the world that private houses are often clad in zinc. These are both private houses and they're both standing seam, but I would say that's about where the similarity stops. On the left is in the Lake District, and on the right, on the Kent coast, curved panels in natural zinc. So the patina there will probably form relatively quickly, being right next to a very exposed location. It still will take several years for it to form completely. It doesn't happen overnight. And this is a building. I don't know whether anybody's visited Stonehenge in the last few years, but prior to 2012, the visitor centre was basically a porter cabin, which was pretty awful for English Heritage's #1 visited sites in England. And it took probably about 60 or 70 years of discussion between all sorts of people, druids and planners and all sorts of people, to accept a plan by Denton Corker Marshall. This is a mile away from the site, so it doesn't impose on the Stonehenge. And you've got areas that school children come to. There's a cafe, obviously closed at the moment, a small museum, and it's very environmentally friendly. There's almost no foundations. It's sat on a very, very shallow foundation, so not affecting the under soil very much. And there's a zinc soffit with these posts, which are representing a sort of a thicket or a small wood, and you can see around the edge of the canopy, the ceiling, the zinc's been perforated, which at certain times of day allows shafts of light to come through, which is quite nice. And then coming back to almost the beginning, on the left, you've got a couple of photos from the Great Western Railway, and in the middle on the top, it says VMZINC Italian pattern. That was on the front of King's Cross. And recently, I was speaking with somebody who owns a spa in Lincolnshire, and which is probably in need of renovation, but it was built in the 1870s. And he took a photo of the back of one of the shingles, the bottom, and you can see Vieille Montagne Liège. So this was zinc that was made probably quite close to that museum that you saw a few slides back, about 150 years ago. Just to end on a really attractive project in an absolutely magnificent setting in the Highlands of Scotland. This is a sanctuary of sick children, where there's this beautiful curved roof and wall that's been created in pigmento blue zinc standing seam. Now, if you would like any more information at all, if you'd like samples or any information on what I've talked about, or there's things that didn't quite make sense, or you need more, or you want to discuss something with a sales manager, anything at all, please don't hesitate to contact us. Go on our website, drop us an email, give us a call, whatever's best. Now, I'm going to see if I've got any questions. If you do have any questions, hopefully they will have come up. Doesn't look like I've got too many questions. One person said they couldn't get audio. I hope most of you can. I see that there's quite a few people that are still on board. So if you do have any questions, please fire away. Any questions at all? Anybody? I've got something here saying, do you have a reference book with standard details? Yes, we have. Sorry, the questions are coming in now. There must have been a bit of a delay. So they're coming in. So do we have a reference book with standard details? Yes, we've got several versions. So we have some on our website, which you can download in PDF and CAD formats. There's also BIM models that you can download. We can send you a pack of drawings as well. We've got drawings in our literature, so there's a number of ways of getting drawings. I've seen the photo. The questions are all flooding in. There must have been a bit of a delay on for me. I apologise for that. Somebody asking about the project in Canada, the music the building by, I think, by Soucy and Perrot. We've got details of that. It's an interlocking panel. If you'd, probably the best thing is if you can drop us an email, we'd be happy to send some standard details to you. That's probably the easiest thing. A box cutter detail, yeah, we've got that. We can go in, there's sort of several versions of that. Next question, how much does zinc expand in hot climates? Well, excellent question. Zinc expands and contracts like all metal. The coefficient of expansion is 0.022 millimeters per meter per degree. So to make that sound a little bit easier to understand, it's about 20 millimeters on a 10-meter panel, give or take. It's not really whether it be hot country. For example, at the moment in the UK, which I don't think many people would describe as a hot country, but there's probably, if you get a high sun, so in the middle of summer, the sun hitting the zinc, and then you get a cloud burst, the zinc goes from maybe 80 degrees down to 20 degrees in a few seconds, and that's when you get real expansion contraction. So that can happen in almost any environment. But as long as you use the expansion clips, that works fine. We would limit standing seam panels on roofs to about 13 meters, because beyond that it gets a little bit difficult. What supporting materials are not compatible with zinc? Excellent question. So you can do cold roofs and warm roofs, and we'll be happy to discuss that in more detail. Plywood is actually not compatible, but we have something called Zinc Plus, which is zinc with an underside coating, which allows you to install the zinc directly onto plywood. So normally there are fairly easy solutions for that. Things to avoid, not substrates as such. Zinc and copper don't get on. Some types of wood, sweet chestnuts, red cedar, all those things, if you put them just above the zinc, they'll stain the zinc below. The zinc won't stain them. Somebody says, can we have a pack of drawings? Yes, we'd be more than happy to send you a pack of drawings. You can download them, or you can just drop us an email. Why can't you go less than 3 degrees? It's a good question, and the reason is zinc, like any metal, to be honest, is not it's not something where water should pond. The joints are mechanical; they're not stuck or soldered. You need to, as we discussed earlier, you need to allow the metal to expand and contract. And in order to do that, you can't solder all the joints together. That wouldn't work. So the water has to shed off the roof. If you go below 3 degrees, you start having a risk of ponding water and water infiltration and staining. So zinc can do lots of things, but it's not a flat roof material. What else have we got here? We're something about sea air, and well, zinc's actually been used on a number of Victorian piers around the country. It was used on the Hastings Pier, which won the Sterling Prize about 3 or 4 years ago. So zinc in a marine environment really works well. The corrosion rate is very, very slow. The only issue is that on non-rinse surfaces, which typically are soffits, you can get staining. Not really corrosion, but staining. Talking about projects with zinc going into cladding into roofing, the best option is standing seam. You can go down to 3 degrees. You can go to vertical. You can go to a soffit. The majority of other facade systems need very steep slopes on roofs. So if you really want to have a roof going to a wall, standing seam, so you can have basically the same panels. You need to have a junction, but it can be a fairly discrete junction. And if you do need photos showing that, we'd be happy to send that over. Excellent question about fire over 18 meters. So zinc is A1, it's metal, it's non-combustible. When you put certain coatings, zinc plus, certain pigments on it, it becomes A2, limited combustibility. So there's no problem about using zinc above 18 meters, but what you do need to make sure is that the substrate and the insulation are non-combustible, or at least A2. So on a few projects we use galvanized steel deck and mineral board insulation, obviously with cavity barriers. So that's fairly straightforward. Zinc underwater is probably not a great thing to do. I wouldn't recommend that. And fire rating for zinc panels. Well, as I said, zinc, basically A1 or A2. What they're then sitting on is a different matter, but it's quite possible to do a zinc facade over 18 meters using only A1 and only A2 materials. Anyway, that's about it. We're coming up to an hour. As I said, if I haven't answered any of your questions, if you need further information, please give us a call, drop us an email. You can see the details on the screen, or go on our website. There's lots and lots of ways of doing it. Just one last question, because it's just come in. Zinc in desert climates. Absolutely no reason why you can't use zinc in a desert climate. Some finishes are going to be more resistant to the environment than others. If you're by the sea with sandstorms, that's pretty harsh. So not all the finishes might be appropriate, but you can use zinc. I mean, zinc's been widely used in a number of quite southern states of the US, and we have used zinc in the Middle East. So it's possible, but you need to get the right product for the right environment. Anyway, thank you very much for tuning in. As I said, my name's Jonathan Lowy. I'm glad you've been able to join us. If you do need more information, please don't hesitate to contact us, and we'll see you soon. Thank you very much. Goodbye.